Hi, this is Lance from the LangChain team, and today we're going to be building and deploying a RAG app using Pinecone Serverless from scratch. So we're going to kind of walk through all the code required to do this, and I'll use these slides as kind of a guide to kind of lay the groundwork. So first, what is RAG? So under Carpathia has this pretty nice visualization that shows LLMs as a kernel of a new kind of operating system. And of course, one of the core components of our operating system is the ability to connect, like your CPU, or in this case, an LLM, to disk, or in this case, say a vector store, or some kind of data storage that contains information that you want to pass into the LLM. And LLMs have this notion of a context window, which typically pass in, like, say, prompts. But of course, we can also pass in information retrieved from external sources. Now, one of the most popular external sources are vector stores. And these have really nice properties, like the ability to perform semantic similarity search. So you can take a kind of a chunk of text and perform similarity search based upon kind of embedding similarity with indexed chunks in your vector store. And so this is like a very popular paradigm for retrieval with LLMs. But it comes with some pain points. So in particular, one is the need to provision your own vector store. Now, some providers, like Pinecone, for example, do have hosting, which has become really popular. But even with hosting, in Pinecone, you do have to pay for your index. And that is a kind of a monthly fee. That is not a usage-based fee. So as of the recording of this video, Pinecone has released this new service called Pinecone Serverless, which addresses these two pain points. It offers unlimited scaling with kind of cloud storage, using GCS or Azure, as well as usage-based pricing. So promised to be significantly cheaper. So this is something that I'm actually personally pretty excited about after having used Pinecone for quite a few projects. So we're going to use Pinecone in this demo and connect it to a RAG app. And we're going to show how to deploy that and how to work with it. Now, some disclaimers. We're going to be using LangSmith and Hosted LangServe for this. So both are in private beta, but you can get access. You can feel free to DM me or other folks in LangChain team if you want access. And I also will share these slides, and I share some relevant documentation down here. Now let's kind of go to the coding section. And first, you can kind of see here, we're going to create our environment. I'm using Anaconda, and we're going to install a few things. So this is the LangChain CLI and also LangServe. So I've done that over here. I've already kind of done those steps. So you can see our environment is here, and we have these packages installed. Now, what you see right here, I'm going to run LangChain app new. So this is actually going to create a new and blank LangServe app. And we don't actually need to worry about this quite yet. This is going to help later when we think about deployment. But for now, what we're going to do, very simply, is just install a few packages that we want to work with. Okay, so this is the Pinecone client that has serverless enabled. And you can see there's an issue related to Python version. So we can actually kind of go here. And this empty LangServe project is actually managed by Poetry. And we can actually look here and we can say, okay, I want to change my Python dependency to match what Pinecone client needs. No problem. So that'll go ahead and install. And we can go ahead and add these other packages accordingly. Good. Good. We'll add Jupyter and just .env for environment variables. Okay, so Jupyter is still installing. Good. So now you can see something that's kind of cool. When we run these commands, poetry add, we can see that our TOML file has these new packages added to it automatically. So our project now has a bunch of useful packages that we want to work with. So that's great. Now, typically when I'm building a RAG app, I start with a notebook. And so, for example, I like to use Jupyter notebooks, obviously really convenient. And we can see here that let's spin up a new fresh notebook. Great. We'll select a kernel. Notice this is nice. So we've created a new LangServe empty project. We've added a few packages we want to work with. We spun up a Jupyter notebook. So next, I want to walk you through the process of actually kind of prototyping some RAG code in our notebook. Now, I'm going to start with some code they've already used previously, just to kind of ease things a little bit and save time. But we can kind of walk through what's going on. So first things first, we're going to perform a bunch of imports. That's fine. And this is actually an interesting point. So the folks from Pinecone have actually created a serverless index already and have given me access to it by providing a Pinecone API key, environment, and index name. So this I already have. I've set these keys, and I'm just simply defining them here. And one other thing I want to highlight is that this index was created from this data set, which is a dump of Wikipedia available on Hugging Face with Cohere embeddings. So I'm going to kind of make a note of that. This is our data set right here. So we have the serverless index, which contains this very large data set of Wikipedia dump that was provided by Pinecone. We're going to initialize our Pinecone client. And right here, you can see that we're actually defining our embeddings as well as the vector store. So now we've initialized our serverless index. We have access to it. And now it's a LangChain retriever, which we can use. Now, the second piece here is when RAG apps, we typically define a prompt something like this, which is basically saying, answer the question based upon only the following context. You have this variable for context, and you have this variable for question. Okay. Now, let's define our model. So here's our LLM. We're going to use OpenAI, and this is a recent large context LLM that has 128K context window. So that's pretty cool. Now, this is where it's kind of interesting, and I want to kind of walk you through this a little bit carefully. So LangChain expression language allows us to compose elements. Like you can see, we have a retriever defined, we have a prompt, we have a model. We can kind of compose these very easily into a chain, okay? So we're going to call this LCEL chain. And what's happening here, very simply, is that we are using our retriever to extract context relevant to our question. So what's happening behind the scenes is when we run this chain, it's going to take the question, perform similarity search using that question on a retriever. And of course, we defined our embeddings of choice. So it's going to be using Cohere embeddings. So it'll take the question, embed it using Cohere, perform similarity search on a retriever, and then those documents that come back are going to be passed to this context key in our map here. In addition, a question is going to be passed through from the user to our map and saved to the key question. Then this will be plumbed into our prompt, which you indeed see expects question and context. We'll then plumb that to our model, and then we'll clean the output. So let me define this. And okay, let's make sure we have everything defined here. Good. Now, what's nice is this chain is a LangChain expression language object, which means that it has a runnable interface with a few invocation methods that are consistent for any LangChain expression language object. So we can call like stream, we can call batch, and we can call invoke. And we can invoke with a question. So again, this is Wikipedia, it contains lots of information. Let's just say, what is film noir? Like it's kind of a completely random question, right? And now this is spinning. Now, what I like to do here is I like to kind of look behind the scenes and see what's actually happening. And so to do this, I will pull up LangSmith. Now, I mentioned previously in the slides back here that I have already set my LangSmith API key, and I've already become a user of LangSmith. So what happens when I go to just langsmith.com, right here, let me just make sure I'm in the right user. Okay, so let's go to my personal user. This is what you see when you kind of go to smith.langchain.com. I can click on this and see all my projects. And this RLM is just kind of my default project. I can click here, and I can see something kind of neat. See this question right here? This is exactly what we asked right here. What is film noir? And the trace associated with that chain is now logged automatically to LangSmith. This is pretty nice. So I can then inspect what's going on. I can look at this retriever object and I can actually look at the documents that have gotten retrieved from that query. And they all are related to this question, what is film noir? But we can see something kind of interesting. The chunk size is variable. And I was kind of intrigued by this. I wasn't sure what's going on. Of course, this data set's from a third-party provider. We didn't actually make it ourselves. So it's possible that there's some irregularities in the data itself. But let's go back. We ran our chain. We can see our answer. You know, it looks sane. We can check our chain here. So again, here's the retrieved chunks from our serverless index. We can go look here, and they're all plumbed into our prompt. So that's pretty cool. And here's our answer. Now, I noted that the retrieved chunks look a little bit weird to me. So some of these are kind of small. So let's try something that's like kind of a nice trick. I'm going to show you a kind of fun page I like. So this is a blog post we wrote kind of a while back, talking about RAG and the various approaches to improve RAG. And I'll of course share this link. But if we look at this diagram here, there's a few different places that we can think about kind of improving our RAG chain. So initially we can think about like if we have a raw user question, we can transform it in some way. We can query, you can use routing to query different databases. We can use query construction if you want to go from like natural language to SQL or Cypher for graph databases. There's all sorts of tricks you can do when you're doing indexing. But I want to draw your attention to post-processing. So this is like you've retrieved the chunks and you do something to them prior to passing them to LLM. So this post-processing is like a really nice area to think about because it's given a set of chunks, what do you do with them to enrich them? And we can actually look here, we can see these retrieved chunks, and each of them has this URL in the metadata. And let's just say we wanted to expand the context. So like for every chunk, instead of just this little subsection of the document, let's go ahead and expand that out. What if we could go to that URL, grab the whole page, and just pass the whole page to the LLM? So it's kind of a way of like, you can think of it kind of as like a context expansion. So from these smaller chunks, I want to go ahead and fetch the full page. Now we can do that, and we actually have some code for that already written. So that's, you're going to see that right here. So all that's doing, so again, we saw our chunks, that's capturing this context variable. And then for each chunk, we're going to get the metadata, the URL. We'll split it to get the ID. So you can look at these URLs. You can see the ID is the thing that's different between each one. Get the IDs as a list, and then call this Wikipedia method for each one, and just get the raw page. That's all that we're doing. Now, what's kind of nice then is we can redefine our chain here. Let me move this around. So here's our chain. And what we can do is we can basically call this function in our chain on the retrieved documents using this runnable lambda. So we're piping our documents to this function. The function is then processing each one, as you can see here, and it is extracting the full context from the URL, and we're going to pipe that into the prompt. So let's have a look at what that looks like. There we go. Run invoke. And it is running now. So we can go back to LangSmith and we can have a look. So we can see it's running. That's great. Now we can look at the retrieval. Okay, so it's the same as before. That's exactly what we expect. Now let's see if this is finished. Okay, it looks like it is done. Or at the very least, it looks like the prompt is here and the output is still getting generated. So that's fine. But let's look at the prompt quickly. So here you can see that these look like full pages, actually. And you can see there's some HTML in there. That's kind of fine. Okay, and it looks like it is completed now. So let's actually maybe refresh this. Okay, there we are. There's our answer. Cool. So yeah, it looks like we were successfully able to extract the full pages and pass all this context in. So this is kind of a means of like post-processing for context expansion. That's what we did. And the answer, again, is kind of sane. You can see it's obviously kind of passed a lot of information that the LM is very, very good at processing and synthesizing, as we all know. So that's great. And that's kind of a nice way we've taken our RAG chain and we have kind of done some minor post-processing to expand the context to get better answers. Now, let's say we want to do a little bit more here. Let's kind of go back. We look at our repo. So not much is here. We just have a notebook, and let's just call this notebook like prototyping. Proto, right? Now let's say we want to actually like deploy this as an app, okay? Now, and let's say this app is going to look something like this. So LangServe is a really nice way to take any chain, as we just defined in LangChain expression language, and convert it into a web service. So each of those invocation methods, you remember we used like chain.invoke. These are all mapped to HTTP endpoints in a web app. And the whole thing is going to look just like this. We have our serverless index. It connects to our RAG chain. We connect it to OpenAI. And this will be a little web app that hosts basically our chain and can expose these HTTP endpoints that map to our invocation methods. And we can access that using a lot of different things then, curl, requests, playground, and so forth. So let's go ahead and do that. And I will take one very quick shortcut just to make this a little bit faster for you guys. What I'm going to do is I'm going to create a new file called chain.py here. And I'm just copying. This is exactly what we had in our notebook, but I just have it kind of nicely formatted, all ready to go. And here it is. You can see it's the same logic. Here's our fetch Wikipedia stuff, fetch URL. Here's our chain. It's all defined. Now, one interesting thing is we put this in the app directory just next to server.py. We've defined this new chain.py. And this has our custom chain logic. Now, here's the crux of it. If we go to server.py, and this is a template example that I've actually already done, but I'm using it just to highlight what's going on here. What we can do is import from chain the chain, and we'll call it whatever we want. And now what we're going to do is this add routes thing, which I'm going to explain in a minute, that basically connects our chain to the web app. And in particular, let's have a look briefly here at what is going on. So add routes and server.py creates HTTP endpoints that expose the methods of the RAG chain on our web server. That's really what's going on. So it's pretty neat. Now, that's cool. That's all you had to do. So I'm going to close the notebook down. Let's just make sure everything's installed. Oh. Install. Good. Cool. So that's all set. So again, all we've done is we've taken our logic that we prototyped in the notebook. We've added it to chain.py. Then we have server.py. We imported the chain. So again, go back here. Chain's here. We imported that. And we did this add routes thing, which connects that chain to our web server endpoints. That's great. Now, all we need to run at this point, I'll just show you here, is langchain.serve. And this should spin up a little, look at this, very nice. So it uses Fast API. And we can see the invocation methods of our chain are now HTTP endpoints in our app. That's pretty cool. And what we can do, which I really like, is we can use a playground to interact with it. So here we are. Now this is just another way of interacting with our chain. Again, remember in our notebook, we were prototyping in the notebook. Let's try the same question here. What is film noir? Now this should just work. This will interact with our app in the exact same way. So it's running now, and we'll see once that starts generating text. Okay, cool. So it starts streaming. We can see it's producing an answer probably pretty similar to what we saw in our prior testing, which is pretty nice. And so that's great. If we go back to the code, again, we prototyped this in a notebook. We then took the logic we want and created this chain.py file, which basically just encapsulates our chain. We very simply just add it to our app using add routes. We import it here, add routes, and that hooks up the invocation methods of that LangChain expression language object to the HTTP endpoints of this LangServe app. And then we can see the endpoints all here. These are endpoints. And then we now have interactive playground here. So that's great. So we've gone part of the way where we've gone from prototyping to a web app that's running locally And we can even take this one step further. Now, this, of course, is optional. And hosted LangServe is still in private beta, so not everyone will have access to this currently. But again, DM me. I'm happy to kind of get you access if you're interested. I've taken one shortcut where I've actually taken the logic that we see in this repo, and I've pushed it to GitHub, so we can see here we are in this GitHub project. We can see it's the same code, so nothing different here, right? Now we can do something that's pretty cool. We can go to LangSmith, and you can see this deployments tab. Now, of course, this is my personal account. I says to sign up here, and this is the process I'm happy to kind of give you access to. I actually already did this. If I go to my LangChain org, I look at deployments. Okay, so they're loading. But I can click this new deployment, and this I can just very simply enter the URL from GitHub accordingly, name my deployment, and I can then run it. Add my environment variables, submit, and then this will be deployed. That's really all there is to it. So again, here I can set different environment variables. I can name my app, just add the repo, and you're done. And you can see right here, we have a bunch of existing deployments. And I'll show you, we actually have this Pinecone app from this repo. We basically just recapitulated. It's already running. If I click on this deployment link, it actually should take me to a page that looks very similar to what we saw when we were running locally. It'll be those same, here we go, very nice. So you can see it's the same invocation methods, but now simply on this hosted app as opposed to running locally. And in the same way, we can actually run our playground through this hosted app. Very good. Nice. So this will spin up the playground. Look, it looks the same. What is film noir? And again, this is connecting still with our serverless index, but now this is, you can see this URL is just hosted on the web. This is not running locally on my machine, and this can be shared with kind of anyone. So it's kind of a true, hosted application that just runs out in the web. It streams. So that's really kind of the nuts and bolts of this, going from all the way from, let's kind of go all the way back up the stack. What is RAG? Setting up a project that uses LangServe. Now, initially, we didn't care about LangServe. We just did prototyping in a notebook. So that's great. That's easy. We defined our chain. And look, in a lot of cases, you only ever want a prototype, and that's completely fine. But what's kind of nice is with LangServe, if you defined your chain using LangChain expression language, you can just take this and just run it as a web app really out of the box. And we showed that because we can just define this chain. And this is all we have to do. We define our chain, we import it, add routes here, and then the invocation methods of the chain are just HTTP endpoints in our app, and we can call it accordingly using our playground, or we can then even go further and host it as a managed service, and how this runs on the web. You can see right here, this is our hosted app. So that's about it. I just want to kind of give a quick walkthrough and maybe give kudos to our folks from our friends from Pinecone for the release. Serverless should be really cool. I've definitely had some pain points with Pinecone and basically paying for indexes I never use, and so I'm really excited for this. And hopefully this shows you how you can take an index and very easily kind of build an app that can run locally, or you can host on the web really easily. Yep, I'm happy to answer any questions. We'll make sure this is all public. Thanks a lot.